Hello, welcome to Ekidel. My name is Justice Nwoka and I am your instructor. Today, we will be learning how to perform a structural design for a concrete building. And we will be using this building plan as an example. This building plan sample here is a 5-bedroom residential building having a 1-bedroom at the ground floor and having the other 4-bedroom at the first floor, which is the upper floor. So this is just a 1-story residential building containing a 5-bedroom duplex. So we will be using this building plan to perform our structural design lesson, and the software that we will be using to perform this structural design is Protastructure. So we will be using Protastructure for the structural design of this 5-bedroom story duplex. Now we will be exporting this building plan into Protastructure. Now, before you must export a building plan from AutoCAD to a Protastructure, you will have to panel the building plan, and also you will also have to provide or position your column points and also provide your axis or your grid positions before you can export a building plan into Protastructure software to perform your structural design. And before you must do that, you have to create 2 layers, 1 layer for column and 1 layer for grid. So I will just quickly create this layer and call it column. Then I'll also create this layer and call it a new layer and call it grid. So this is just the 2 layers I need to do my structural framing before I export it to Protastructure to start our structural design. So now I'll quickly activate my grid line first. This place column must be by layer, your line type must be by layer, and your line type by layer, line width by layer, sorry. So now I will also have to create my axis. To create axis, I will use construction line. I'll use shortcuts to do most of this drawing here in AutoCAD. So I'll quickly say XL, which stands for construction line, and I'll say vertical. So I want to create my vertical axis. So I'll quickly place this axis at the midpoint of this wall. That means I now have my vertical axis on this wall. I will also go again XL for horizontal H, and I will place this. So now I have my axis, my vertical axis and my horizontal axis. I'll quickly copy this right now using CP, copy, picking a base point, and copy to all the horizontal walls. Okay, to all the horizontal walls, and then I'll copy the vertical axis also to all the vertical walls. So I'll copy vertical axis to all the vertical walls. Okay, by the time I'm done, then I will now have to go and activate my column. And to create my column, I'll use rectangle to create my column. I will start with a default column size of 225 by 225 millimeter column size. So I'll say 225 by 225 column. I'll copy or move this from midpoint to this place. So, and I have established my first column point, which is at the edge. I will have to copy this column and start positioning or putting my column points on this building. I'll pick this point. I'll pick this point. I will advise that your column points should not be more than 8 meters. At least should be ranging from 4 meters between the space between or distance between each column, 4 meters, 5 meters. That is a good advice for a structural to perform a structural design. So you just from your own example, the plan you use, you quickly put your column points and panel it. The panel simply means how you want your beam and how you want your beam to run and your slab to run. So with this now, I can quickly go and say, okay, I want this region to be one panel. So I will eliminate this when I'm doing my when we are performing the structural design at Orion, at Protastructure, we will quickly eliminate this. So by the time you're done, you will get something. So by the time you're done, you have something like this. Now, this is this building plan now is ready to be exported to Protastructure. As you can see, I've positioned all my column points and my grid lines. So with this now, we cannot export this plan to Protastructure. To do this, you have to save only this plan with DSF format. So you just select and use the shortcut W, enter. When you do that, you save. You pick where you want to save it. I'll pick a place in my desktop, and then I would just type structure plan, and the main thing is to pick the format DSF. So I'll pick DSF and I'll save. I'll save it on desktop, and I will just save and say OK. So with this, we can now export this DSF file to Protastructure and begin our structural drawing. So I'll quickly minimize and go to my desktop. This is it. We have it here. So we will export this to Protastructure and begin our structural design. Thank you. Have launched your Protastructure software. When the Protastructure software have finished loading, this dialog box will appear. So to begin your structural design using Protastructure, what you have to do when this dialog box has appeared, you have to click on a new project. So when you click on a new project here, you will have to specify the project code, which simply means the project name. So what I'm doing right now, you can use the client name or you can use the client name and the kind of building that you're doing to name the project. So what we have here is a 5-bedroom duplex. So I will just say 5-bedroom, 5-bedroom duplex. And I'll quickly put the client's name, Mr. Tega. Then I'll click OK. Wait for it to appear. Now, once it appears, you will be using BS 8110, UK BS 8110 for this structural design. So we'll be using British code. So I'll quickly choose UK yes 8110 and click on import. So once we click on import, immediately it imports all the design parameters, all the design elements that we will use, design formulas that we will use to perform the structural design. So I'll click on import. So I'll wait. So right now it's trying to import everything, and this is the DSL file that we are going to import into Protastructure. So we just wait for it to come up. Okay, it's coming up. It's coming up. Okay, I'll quickly maximize this and then I'll click on save. I'll say cancel. Now we want to import our GA drawing. GA simply means general arrangement drawing. So what we call this here is a GA drawing, structural general arrangement drawing, because once you arrange your columns and your axis on a building plan which you want to perform the structural design, that scenario is called general arrangement drawing. So we have arranged our column positions on our grid, about to perform our structural design using Protastructure, and we have, from our previous lesson we just took, we have saved this as a DSL format, which Protastructure accepts. So I'll quickly go and to import from AutoCAD into Protastructure, we will click on building setout. Okay, to import into Protastructure from AutoCAD, we'll click on external reference drawing, which is this icon here. You can also get that icon from file. You go to model file imports and external reference drawing. You click this. Then we wait for the dialog box to appear. A dialog box will appear which will prompt us to choose or to load the DSL file. So we just wait, hold on for it to come up. Okay, so then we will click on load DSF. We'll click on load DSF, and we'll be asked to choose the file. So we will quickly go to where we saved our general arrangement drawing, which is on the desktop. And so click on desktop, go to desktop, and then locate where we saved our file. You can see it here, structure plan. So we will go and click and say open, and then we allow, now the importing process is taking place. So we allow it to import properly. Yes, we will be using millimeter for our measurements. So I'll quickly say okay, and then I'll set to use the color of the plan, which then I will now import. We will now click on import members. You can see our plan is here. We will now have to import members. This is where you have to import your axis and your columns. So we will now click on import members and import axis as grid line, import column as grid line. This, I hope you remember that we set at this place, we set two layers, grid and column. Which column signifies our column and grid takes our axis. So in this place now, Prota is asking you, what are you importing as axis? We say import axis as grid line and import column as column layer. So we now click on OK. Then we wait for the axis to load. We are waiting now for the Protastructure to identify our grid line as axis and our our column layer as column. So let's just wait. Okay, we will this is just a bidding check. We say start. It's trying to check the imported file if there is any error, like in clashing of axes or clashing of two columns together or overlapping axes. So it's trying to check. So the check is done. Zero error, number of errors 0. So we have no clashing axis or column. So just say close. Okay, then we say close. Now we have our axis imported and we have our columns imported also. So now that, if you can see right now, we have our column imported and we have the shape of our plan, of our bidding plan imported, which is right here in AutoCAD. You can see also the shape, the staircase area, and the veranda, the anteroom, the living room. If you come back to Protastructure, we have the same thing, the staircase area, the veranda. This is the area of the anteroom. The text didn't come with the imported file, but we have our axis and we have our columns. So with this now, you can now begin to trace and do your structural design. So this is how we import our floor plans from AutoCAD down to Protastructure for a structural design. Thank you. Okay, so once done importing your floor plan into the Protastructure software, then the next thing to do is to, after, now you can see your columns already placed as arrangement from AutoCAD. Now, once you're done with that, the next thing we'll be doing right now is to place our beams. So I'll quickly click on beam and then I'll set my beam. I want to use a beam of 2.5 by 450 depth, 5 millimeter by 450 millimeter, and then I will click at this point and drag it to this end. I have a beam all there. Is our first beam. The next again, I'll click. Now I'll click again. I have a beam running towards the axis. And then, let me see. We will have to put a column at this point. We missed it. We'll put a column at this point. We missed it. So we will need a column to be at this end. So I'll just escape. I'll click on escape and place a column at this point. We need a column here. Column of 225 by 225. I'll place a column here. Then come back to our beam and continue. This is a practical based lesson because this is a structural design that I'm doing for a client. So this is a practical base. It's not just a lesson, it's a practical base. So I would advise you just take it serious. I'll quickly place all my beams. I'll just place my beams, draw it here. Then I'll begin to place my internal beams. I want this beam to run this end, and then this end, and then this end. So now we don't have this as one panel, as a panel. So next I'll place again the beam around the staircase area. I'll continue again. Okay, continue again. I'll be a little bit fast so that we can be able to meet up time. Okay. Next I have here. Next I have here. Next I have here. This beam is not properly placed, I think. Yes, it's not properly placed. I think it's placed at eccentricity of 50, which is meant to be 0. It's meant to be 0 because you can see it here. It's not really flushing alongside with this beam. And as you can see, like I said, this is a practical base, so this design is for a client. So I just said let me use this to create a video, a lesson video, so that it can be beneficial for everyone. Okay, let me see. I want the beam to run at this, okay, to flush here. So I'll just go back and flush my beam here. Then I don't want any beam around here again. I want here to be a panel. Okay. So now I want a beam to differentiate this staircase, and this place is to be for a landing for me. So I'll just put a beam across to differentiate that. I'll place a beam here, or I'll come further this way and place a beam around this area. If I place a beam around here, it might anyone is climbing this staircase. So I'll place the beam around here. So I'll go back and place the beam around this area. And then, so this is my staircase hall right now. Then what again? Do I have anything again here to do? Okay, I have, okay. Okay, let me come to this area. Go this way right now. I go this way right now. Okay, let me see what's happening here. Okay, nothing's happening there. Okay, I have now my beams are properly placed. The next thing I want to do is to insert my slabs. So I'll click on the slab icon and set my slab thickness as 150 millimeter. My slab concrete cover as 25, using the slab depth as or thickness as 150. Then slab load, dead load, I will input my dead load to be 1.5. What kind of building I'm designing for. We are doing a structural design for a domestic building, so I'll quickly choose the general domestic use, and then I will begin to insert my slab by clicking on the panels. So I'll click on each panels to insert my slab. Okay, by the time we are done, now you can see we have inserted our slab. all our slabs are already inserted. I'm very careful because, like I said, this is a practical based learning, and this design is a practical based design that we are doing. So you have to check properly to check if everything is intact. This bin is not okay. It's at a sensitivity of 50, I think so. 25, so it should be at 0. Okay, now it's not flushing. Okay, then we'll go again. We go again. Now we have inserted our beams and our slab. So the next thing now, is to insert cantilever slabs. When I contacted the client, we have a cantilever slab right here at this region. So is to insert a cantilever slab because there is difference in size between the ground floor and the first floor. So that is why we have these cantilevers around this area. So we will need to insert the cantilever slab on Protastructure. It is on this plan. You can see we have cantilevers almost all around this building plan. So to insert the cantilever, and the cantilever length is 600. I think they are all uniform. So to insert the cantilever slab, or to create a cantilever slab in Protastructure, what we have to do is to first offset the grid line, because our cantilever length from the face of the wall down to the face of the cantilever is 600. So we have to offset the grid line. We have to offset this grid line. To offset this grid line 600. But now, don't forget, the cantilever length of 600 starts from the face of the wall. So if we are going to offset, we will have to add the distance between the center of this beam to the edge of the beam plus the cantilever length of 600. So our beam width is 225 by 2 is 225. So we will quickly say 225. We will quickly say 225. So we will quickly do 225 divided by 2. So 225 divided by 2, we have 112.5. So from the center of this beam to the edge of the beam is 112.5 millimeter cantilever length, which is 600. So plus 600, we have 712. So approximately we have 713 millimeter. So we will have to offset right now 713 millimeter. So we will click and offset this grid 713 millimeter. And to offset in Protastructure, you will hold F2, key F2, then type your length. So I'll quickly press key F2 and type 713 and I'll say enter. Okay, now we have offset this. The same thing goes to this. Since the cantilevers, they are all uniform, so the same thing applies to all areas that will have cantilever. So I'll quickly do the offset. We have the cantilever at this back, as you can see here. We have it at this back. We have it on this area also. We have it almost at every face. We have them. So we'll offset this again. I will press my F2 key, F2 key, F2. and 713. We are going left. So since we are offsetting on the left hand side of the screen, when you press your F2 key, you have to put minus 713, sorry. Then we'll press enter. The same thing happens when you're going down. Do we have a cantilever at this area? Let me see. Yes, we also have a cantilever at this area. So the same, we offset this. Press F2, enter. Then we also have a cantilever at this face. Yes, we have a cantilever at this face on the balcony, on the veranda area. So we'll also offset this. We are going down, we also use minus. So you press F2 key, minus 713, enter. We don't have a cantilever on this small face. I don't think we have that. Let me see. We don't have that. So we have cantilever at this longer face. So we have a cantilever at this face. So we will offset this using our F2 key, 713, enter. So now we have finished offsetting our cantilever length. The next thing now is to insert the cantilever slab. So we will do that by clicking on slab and then choosing our slab thickness, the same thing, 150 millimeter, cover 25 millimeter, load the same, everything happens the same. But now the difference here is that we will have to now click on the type of slab. 12 symbolizes cantilever. So in Protastructure type 12 is for cantilever slab. So click on 12 and then let's begin with this face. To insert a cantilever slab, you go anti-clockwise and not clockwise. So if I click here to here, I'm going anti-clockwise. What happens is that the slab will come in on this area, on this region, will come down. But now we want our slab to come out, which is on this region. So I will have to click. Okay, we will have to input our cantilever length. So 600. And then I will click anti-clockwise. Sorry. Anti-clockwise, this to this. Okay, we have that right now. This to this, we have that right now. This to this, we have that. And then, okay, we notice that we have not put our cantilever load. So I'll quickly edit one of the cantilevers. Our cantilever load, which is the load on the edge of this cantilever, is 9.81 kilonewton. So I'll quickly say update, and you can see the symbol of our load. So I'll just do that for all. Right click, properties, go to load, apply my cantilever load, 9.81, update. I'll go again, right click, properties, load, 9.81. Okay, so the same, we do not continue. We click and click. When you're inserting your cantilever, you have to insert cantilever column to column and not column to another column. You have to do column to column. If you have
up to 3 columns, you have to do it between each columns. So click here, click, automatically it has formed the shape that we have here. We have this kind of shape here. So we go back again, we go again, click outside, then we don't have, let me see, we have a cantilever on this face, on this area. So we also go and say okay, we have to do this first, this 600, this 600, this to this 600, and this to this by 600. Let's see again what we have again. Okay, so we now have this shape of this cantilever on this area. As you can see here, we have our cantilever right now, the shape with our cantilever loads already inputted, which is 9.81 kilonewton. Then we have to move over to this side to create cantilever on this side. Let's see how the cantilever on this side runs. Cantilever on this side does not run all the way down. It started from the staircase region here. That's where it started from, the staircase region here. It started from here. I see the cantilever started from here. So we will start from the staircase region all the way down. So we move right now back to Protastructure, and our cantilever started from this area. So we'll move from here to here, 600, from here to here, 600. Okay, all the way down this side. So we again from here to here, 600. Then where again do we have? We can see that we have now established this cantilever. You can see the shape here. You can see the shape right here. We have it right here. So we go again. We have a cantilever on this veranda area, 600. So we go. The area we have the cantilever is just on this area. So we say this to this all the way down. So this is how we insert our cantilever. So let's just take a 3D view of how this looks. So to click a 3D view, you go to the Storey and right click and click on 3D view. So we wait for it to load. Now you can see our cantilever and then our loads on top. This is how we create cantilever slab in Protastructure. You can see the staircase hall, the staircase area. So this is how we create cantilever slab on Protastructure. Back to plan view. Okay, after creating our cantilever slab, the next thing we will have to do is to insert Storey. Now, looking at this is just, we only have one story upward. Now, because of our cantilever, you can see that some of the columns, when we insert our Storey, that is the Storey 1, the first floor, this column will be terminated on the ground floor. So we will have to delete and shift this column from this area down to this area. Like I said, this is a practical base training. So all the columns having the color of magenta will not extend to the roof, while all other columns will extend to the roof. All other columns with green color will extend to the roof. but the columns having magenta will not extend to the roof. It will terminate on the slab because it is not because of the cantilever that we have, so it will have to terminate on the ground floor. So now let's go back, going back to Protastructure. Now, many people like to insert Storey once they are done with their modeling, but for me, I'm not done with my modeling until, just as it is when you're doing your when you're performing your structural design manually. You know, at this area, we will have to obey the fixed end or the pin end or the roller support and all that. So I always obey the fixed end and the pin end condition. So at this area, I always hinge, because you know, moment at an end must be 0. So this is a continuous beam. This is a continuous beam. So the moment here must be 0, and the moment at this place must be 0 because there is no beam continuing on this area. So right now, as it is right now, they are all fixed. They are all fixed conditions. All the ends of the beams are fixed conditions. So I always like to introduce a hinge, knowing that moment at an end must be 0. Most people don't do this, but like I said, this is a practical base. I always like doing it. So I'll quickly click on this beam. I'll click on this beam, right click and say update beam end condition. The left end, which is this side that I want to apply my end condition, saying there is no moment on that area, that moment there is 0. So I will say end hinge at left, which is the left. When you hinge, you will see the symbol circle. The circle will showing that the moment at that place is 0, telling you that that place does not have moment and that place is having a hinge support. I'll quickly say apply to selected beams. You can see there. So the moment here on this continuous beam at this end is equals to 0. So I'll also do the same thing here. So this is a continuous beam. So the moment at this upper end is 0. So I'll quickly right click and say right end. In Protastructure, the upper side of your screen is called the J end, the downside is called the I end, and the right hand side of your screen is called the J end, and the left hand side of your screen is called the I end. So right now I want to hinge the upper side of this beam. So if I click and say beam end condition, I'll click on J and say apply to selected beams. You can see. So right now the moment at this place, at this beam end is 0, at this beam end is 0. So I'll do the same for all. The same thing happens here. Now at this end, now this is a simply supported beam because it have both ends this continuum. So at this point now, the moment here is equals to 0, moment here is equals to 0. So I'll quickly right click on the beam and right click and beam update beam end condition and say both ends. Okay. Now the reason why I do this is because most people don't do it. Most people just say, okay, I want to leave it that way and just go ahead. The reason why I do this is because when you do this, you know, when we design, when we perform our structural design, we look at one, the stability and also the cost. So when you do this, you're invariably reducing the quantity of reinforcement that this beam would have taken on this end. You know that if this place, like this beam now, that is meant to be to be hinged, if we leave it right now as a fixed end, it will going to have a tree, either a higher diameter of a higher number of reinforcements on the upper on the compression side or the tension side of the beam. But if we assign the beam end condition, knowing that this end is not continuing, is not continuing, and the end is 0, and we apply the beam end condition as this end to be 0, automatically the quantity of reinforcement that we would have needed on this area of the beam will reduce. Indirectly, you're reducing costs for your client, and also the cost of erecting the project. So I'll quickly do these end conditions for all. Okay, so and also in the area of stability. Okay, so this is how we apply your beam end condition, your fixed and your hinge end. So this side now, this beam now, at this area, we have a hinge end at this beam and a hinge end at this beam. But coming to this beam right now, this beam, this is a fixed end and this is a fixed end, because it has a continuity. So the moment at this area, we have to come. If I want to draw the moment diagram of this area right now, you see that it will come like this and rise a bit because it's a fixed end, so it must have a moment. Rise and go down again, go again, rise and go down again, then it goes and comes back to 0. Okay, so this is how you apply your beam end condition. Thank you. Now you're done with your beam end, applying your beam end conditions, applying your fixed and your hinge, and inserting your cantilever slab. As you can see here, your beams, your columns, and everything is set. The next thing you have to do right now is to insert Storey. So to insert Storey, I will click on building setout, and then I'll click on insert Storey. Okay, I wait for the dialog box to appear. The total number of stories we want to insert. This building is just a one-story building. It's just a one-story building having a first floor, having a ground floor and a first floor. So I'll quickly insert 2. Now, Protastructure takes the ground floor as story 1. Any other story that you're inserting on top of it, you have to put 2. So on and so forth. If you're doing for 2-story building, you have to insert 3. If you're doing for 4-story building, you have to insert 5. So since you're doing for just 1-story building, we'll have to put 2. This does not mean that this is a 2-story building. No, it takes the ground floor as story 1, and the next floor you are inserting as story 2. So as I put 2 here, I'll now put OK. Automatically, it's trying to create the upper floor. I'll say OK. So we wait for OK. Now we have, you can see right now, story 0, 0, which is the foundation, story 0, 1, which is the ground floor. Now we have our story 2, which we just created. Now we have only the grid lines. Now we now have to run generate story. That means we to bring our columns from this ground floor and our beams to this upper floor, to this story 2. We have to click on building setout and click on generate story. Okay, to generate story, you click on story 1 and click on building setout, generate story, and then we want to copy everything that we have on story 1 into story 2. So click on Story 2. We want to copy both the slab, the columns, the beams, and everything that we have on Story 1 to Story 2 then before we begin to do our editing. So we click on OK. Now, this is our Story 1 and this is our Story 2. So we have just copied everything that we have on Story 1 to Story 2. To look at it on the 3D view, we click on 3D view. Now you can see that this is our Story 1, this is our first floor slab, and this is our roof beam. So at this roof beam, the client doesn't want to use slab for his roof beam. He wants to use a normal roof, so we will have to remove the slabs. So I'll click here and go back to plan view, and then I will now begin to make editing for the things we don't need on this Story 2. So this is how we create story in Protastructure. Okay, so now after creating your story, so we now have the foundation, Story 1 and Story 2. You quickly click on the Story 2 and begin to remove the elements that you do not need. Looking at this now, we don't need the cantilever slab and we don't need the slab on this roof area. So we have to remove all the slabs. So to make that very fast, I'll quickly click on this structure tree, click on the first slab and on this last slab, and hold my shift key and click on the last slab, and automatically to select all the slab, and I click and say delete. I'll say yes, delete all the slab elements. So the next thing now we'll do, so looking at this floor plan right now, these columns that have magenta color does not continue because of to the roof. So all these columns having magenta color will have to terminate on the floor slab. So example of the columns. Now let's start tracing the columns that does not follow us to the roof. So this column and this column at this edge does not follow to the roof. So these two columns will have to stop on the ground floor. So going back to this, we are on our second floor, which is the roof level right now. So we will have to delete this beam. We also delete this beam. The two columns we have just deleted right now because these two columns are to be deleted. Okay, so we don't have them again right now. Now, don't forget we have a cantilever on this area, so we will have to extend these beams. Now we'll have to shift to this level, to this area. So either you shift the beams or you just insert a new beam. So I'll show you two ways. Either you insert a new beam or you shift the beam, or you move this beam. So I'll do my end condition right now too. So this, remove the end condition. So this, and then so this, you have a cantilever there. So with this now, we have to extend this to this A because this is a cantilever on this side. We extend from Y, this is axis Y1, so we extend from Y1 to Y12. So extend from, click on Y1 and click Y12 and click on extend. Okay, it didn't work, so just delete. here, here. Now, at this point now, we have created a new beam. So these beams, we have to delete these beams. The reason why you are deleting this beam is because going back to our floor plan here, that beam, this beam that we just deleted right now is on this area. So on the roof level, we do not need the beam here. The beam shifted to this level. So that is why we moved it. So now, at this point, we will have to put a column at this point. Looking at this, from here, we'll have to shift to this point. So the column was right here, so it will shift to this point. Okay. The same thing happens here. The column that we just deleted from here will also shift to this point. So come back. Sorry, column, not beam. Now the column we will not have to put the column on this area like me, because I want the column to be at this edge and not this place. So at this edge, I want the column to be. So I'll come back and put my column here. Now putting my column here, remember that this is our cantilever line. So this column will have to flush on this grid line. So I'll quickly change my column insertion point to this and say update. Okay. So the next thing now, this is serving as a cantilever. So since we have this column going down all the way to the roof, which is this column here, this column, I'll just insert a cantilever beam to carry these two beams on this area. So I will insert a cantilever beam right all the way here. Then I will now have to disassign these two beams as cantilever. I will remove, I'll say both ends, I'll click and update. I'll say mark free end cantilever, I say no, both end. So we now have a cantilever. This triangular symbol here shows that this beam is cantilevering down all the way here to carry these two. Okay, now if you have a cantilever, you have to remove every hinge end at accompanying. Now since this beam now is not continuing, it's not continuing, we will not have this point, this end again as 0 because it now has a continuation. So we'll have to remove this hinge end to a fixed. So I'll right click and I'll say update, no hinge. So this is now a fixed end because it has a cantilever and this beam is in continuation. So I'll just quickly extend this beam. I'll extend this beam from axis 1 to axis 12. Update. Okay. Disassign as cantilever. Supports beam end condition both ends because it has a discontinuity on both ends. Beam end condition both ends. Okay. The next thing now, this we have the same thing happens to this one, to this column. So we also remove the next column following it. So we would also delete this column and we'll have to insert a new column at this point. A new column, sorry, not beam, a new column at this point. Okay, next now we'll have to, like I told you before, I'll show you how to move a beam. Either you insert or you move the beam. So I'll move this beam now to this axis. Right click, properties, and from from axis Y8 to axis Y11. So I'll click on Y8, Y11, Y8, Y11. Now say update. Okay, now this beam will have to also flush on this axis and not this way. So I'll change the beam insertion. We have the axis first, so I'll just say okay, no, not that way. So we have it this way. Okay, yeah, then I'll have to extend this end to meet this column, and this is axis Y, so axis X1, so X1 to X2. I'll have this. I have to remove this cantilever end because it's not a cantilever. This triangular symbol shows that it's a cantilever end, so I have to remove it and apply a hinge end there. I'll remove as cantilever and apply in end condition J, that's J end, which is up. Yes, it's there. So then we will have to also shift this from axis 8 to axis 11, from 8 to 11, update, change the orientation, update, remove the cantilever end. Also shift this, extend this beam to meet this beam. I will have to extend from axis 8, which is axis 8 here, to axis 11, extend. Okay, most times it doesn't work. You just have to, okay, axis 8 to axis 11. That didn't take. Update. Okay, so we have it now. So we have to look again. Like I said, it's a practical base. That's why we are taking this time. The next column we are removing is this column. So everything flushes. So we have a cantilever beam following here, or we just extend. Yes, cantilever beam. So we have a cantilever beam following here, removing the end conditions. So every end condition now on this following this beam will be off, except on this area, which will still be hinge end. So we go and say hinge end at I, which is the left hand side. Okay, let's just look at how this thing looks like on the 3D before we continue. 3D view. Okay, how did you do your editing at this back side here? So now you can see what we are doing right now. You can see what we are doing right now. So this is where we just, now this is a cantilever, you can see it, the cantilever beam we just imputed. So this is a cantilever carrying this beam, and this is the cantilever beam we imputed in this area, cantilever beam that is carrying these two beams and this end. So we'll go back again to our floor plan and continue. I'll quickly pause this and make all other changes. These changes, I'm pausing this just to reduce the size of the video. So I'll pause and just do the same thing we did on this area. Then I will now unpause it when I'm done. So we are going to edit on this area and edit on this area. Everywhere we have cantilever. So let me just do that. Okay, so by the time I'm done making all my edits, all my changes, so that it can align with what we have here on the first floor, on the first floor plan, by taking off all the columns that we have here, that is magenta color. is the cantilever that we now have, which is on this area, Yeah, this is a cantilever that we have on this front area. That's what we have here. Looking at the side, you can also see the cantilever that we have on this side. Here on this side. Okay. This is the cantilever that we have on this side. You can see there on this area. So then also looking at this plan right now, you can see the columns these columns are not extending down to the roof. They are stopping at the slab, which means they are terminating at the slab. So let's look at it here. Okay, you can see this column here is not extending out to the roof, it's stopping at the slab. So that is what we have. That's the column that we have here. Okay, let's look at this column, this place, which is stopping at the slab. Let's look at it. This is the column here also is terminating directly at the ground as the first floor slab. It's not extending down to the roof here. Okay, let's look at these two columns here, which is terminating at the slab also. That would be around this area. That would be on this area. Yes, this is two columns that are stopping directly on the slab, so they are ending out. Okay, let's look at the last column that we have. Okay, not the last, it's going to last at this end of the building. So okay, so this is the column also that is terminating at the slab, which we also have here. Now the last column that is terminating at the slab, which is around this area of the building, so which is also on this area of the building. Okay, so now you can see how we created the cantilever slab and how we arrived to this stage, and also how we did the changes that we have on the ground floor and the first floor. So this is how you do your changes when the ground floor and the first floor are not the same. You have to align with the architectural drawing to fit in your structural drawing. Okay, so now I think we will move to the next stage of creating the partition walls. Now, okay, we will have to create our partition wall. These beams is carrying a partition wall, it's carrying a wall load. So to create our wall load, you click on the Storey 1, which is on the which is the first floor beam. So looking at this plan right now, this beams on the first floor is carrying this upper floor block works. So we will have to insert this block work load on these first floor beams. So to do that, we'll come back to our Protastructure. To do that right now, to insert our beam wall load, we will have to click on one of the beams on the first floor, which is on Storey 1. Right click and go to edit beam wall load. Click edit beam wall load, and then we'll allow it to load. Why the dialog box appears, or before it appears, you have to insert your beam wall load on the Storey 1. If you're doing just a one-story building, you install it on the ground floor or on the first floor beams. Okay, so right now we input our wall unit weight, which I want to use 3.7, which we use in this country. We have to put our wall height. Our wall height from the architectural plan is 3.15 meters. So if we have 315 meters, 3150 millimeters. So if I minus my beam depth is 450 minus my slab depth, which is 150, I'll have my beam depth to be 300. So now if I minus my floor height, which is 3150 minus 300 the beam depth, this gives me the adequate height of which the block wall will contain. So this is 2.85 meters. So that's what I'm going to put here as my wall height, 2.85 meters, because the rest is being occupied by beam. So 2.85 meters, and my wall thickness is 225. As you can see it here, 225 is wall thickness. So in meters, 0.225, and I'll just say okay. So when you do that, you see the symbol will change. The beam will be hashed. The beam will be hashed. So I'll click on this beam again and copy. I'll go and say copy beam wall load, and I'll click on the first beam to make it fast, and I'll click on the last beam, and I'll say paste copied beam wall load, and I'll say okay, yes. Now we all have our beam wall load now all pasted. Now mind you, remember that we have a cantilever on this end. So all the wall loads that are meant to sit on this beam, we have already transferred it to the edge of this cantilever. That's why we have the edge of this cantilever loaded, because all the walls on this end was shifted to this end on this first floor plan. That's why we don't have any wall along this side. So we will have to remove the wall load on this area, align on the area we have cantilever. So I'll quickly select them, right click and say delete beam wall load. I'll say yes. You can see that now the wall load of these beams have been deleted because there is no wall sitting on this beam. We already have this cantilever edge loaded to carry all the walls that will sit on this area. Same thing happens to this area. That's why I said this is a practical based training. So I would say just sit tight and practice and learn. So we go again and remove this, remove this, also and right click and say delete beam wall load, delete beam wall load. Mind you, we are not taking the beams off. What we are taking off is the beam wall load that we inserted on these beams, not all the beams, but these beams along the cantilever area. So I'll click again, and click again, and right click and say delete beam wall load, delete beam wall load. Come here again, right click and say delete beam wall load. Okay. Now let's look at it at our 3D view. We go all the way. Right click 3D view. Now you can see that we have already our partition walls showing. We have our wall load inserted, which is wall load on the beams. You can see that. Okay, so go back to plan view. So this is how we insert beam wall load on our beam wall load. The next thing we are going to do, editing the story simply means to input our story height, the height of the story. Looking at this right now, going back to our 3D view, you can see that we have not done anything to the height of this story. to say what is the height from this DPC level to the soffit of the slab, and the height of this floor level from floor to the roof. We haven't done anything like that, so that's what we want to do now right now, to insert the story height. So to insert our story height, let me go back to plan view. We quickly go to building setout. This tab is very important, building setout, and we go to edit story, and this is the place where we're going to insert our story height if you have different story height from the ground floor and the first floor. So the ground floor story height, we have 3150, and the first floor remains at 3 meters. So this area now shows what is our first story bottom level. This simply means the DPC. So what is our first story bottom level, which is the DPC height? So I will say 450. That's what I want to use, 450, because the place is not a really waterlogged area. So I will use 450, and I don't want the DPC to be very high, so just to avoid excessive filling of laterites and hardcore materials. Then I'll specify my temporary foundation depth. Let me say 2 millimeter. This is just temporary. At site we can change that, so I'll say okay, and I'll say yes, continue. If you look at this right now, you can see that we now have our first story bottom level as 0.45, which is the DPC, and then we have our story 1 height as 3.6 meters, and if you add 3 meters to this, it's now 6.6 meters. Okay, if you look at the 3D view right now, this is what we have now. You can see that there are changes on the height. This is 3.15 millimeter, and this is 3 meters. Okay, so this is how we add our story height between each floors. Our story height and the difference, and editing our story. We thoroughly check the 3D and everything is in place. The next thing we are going to do right now is to analyze the structure and design the structural members. So we go back to our plan view. Now, to perform our analysis on the structure and also to apply and also to design the structure, we will click on Analysis tab and click on Building Analysis. Then we will go further on clicking on Editing Materials. This is where we will choose our concrete material, and so choose our concrete strength. Our concrete strength, I'll use C16 to 20, which is the cube strength 20, and the cylinder strength 16. So I will just say apply to all. And that's what I would have done. I'll say apply to all, since it's all concrete. Apply to all. Then I'll go for steel, which is the reinforcement. I'll choose 410 type 2. I'll say apply to all, and I'll say okay. Then I'll go to foundation and check foundation. I want to use the same, and say apply to all. Click. We have the same thing. Then for foundation diameter bar, which is the diameter, I want to use I'll just quickly select all and select, then pick the ones I want to use. I want to use Y12, the diameter 12 for the reinforcement of the foundation. I'll just say okay, and the links, I'll just select all and deselect, and I'll choose only diameter 10, which is Y10. I'll say okay. Then I'll go to default materials. For the column reinforcement, I will select all and deselect, and I want to use only Y16, which is diameter 16 for the reinforcement of the column. And then we don't have wall, so I'll skip concrete wall. Next thing we'll have is beam. I'll choose diameter of beam, select all and deselect. And I want to use only diameter 16, which is Y16 for the reinforcement size of beam. So I'll select only that. Then I'll go for slab. Slab, I'll select all and deselect. I want to use only diameter 12, which is the reinforcement diameter of size of 12. I'll say okay. Then I'll go. We don't have rib slab, so I'll skip rib slab. We have links which we use for the beams and the columns. So I'll select all and deselect and choose only Y10. This is diameter 10, which is Y10. And then that's all. We don't have polylines, we don't have all this. These ones are for steel. So I'll quickly say okay. Then we can see we now have changes done, and all our concrete materials is C 16 and 20, and our reinforcement steel grade is grade 410 type 2. Then I'll go on by saying loading combination. I'll click and I'll just say, and I'll click on loading generator, and I'll say okay, and I'll click on okay, and I'll just say, then I'll go to parameters. This is where you can change the code if you want to change your code, but we are using BS 8010, which is the British code. So I'll quickly go to foundations. The bearing capacity, which is the bearing pressure from the geotechnical report, is 135. So I'll go for lateral loading. We don't have any lateral loading on this building. We don't have any lateral drift. Then I'll go for title. The project header is 5 story. Sorry, not 5 story, 5 bedroom. Bedroom duplex structural design, or just say design. Made by is made by me, Engineer Justice. Checked by my boss, Engineer Peter. Project number 01/04. Project date, the date which this project is done is 20th April 2022. So I'll just say 20th 04 2022, and I'll say okay. So with this, I can now click on analysis. I'll click on check all, and I'll say with select bar if any failure. But I know we don't have any failure. We won't have any failure. So I'll go and click start. So with this now, by clicking start, we are trying to analyze this whole structure right now. The building analysis have started. It took only 0.78 seconds to perform the building analysis, which is almost done. Okay. Now we are about entering to column design. Now it's trying to design the column. Now we have entered the design stage, is performing the column design. Now we have entered the beam design. So it's performing the beam design. Will soon be done. This is the last stage. Then we'll now enter into foundation design. By the time we do our foundation, we carry out our foundation design, then we are done with the design stage. We will now enter into structural detailing. So the beam design is almost done. just wait a bit. It doesn't take time that much. So I think you're okay. Now we have the building analysis is completed successfully. So click on OK and then click close. So looking at this now, we will have to, this is how you perform a structural analysis and design after modeling all your structure. Then the next thing we'll do right now is to go for building interrogation. We'll have to go and interrogate with the design. So we'll click on visual interrogation, which is this icon at this stage, at this area. Click on visual interrogation here. So clicking that right now, I want to see the design area. So I'll take design status and I'll click on OK. So knowing that any color, if you have any color green means that your design is perfectly okay. Red means that design, that structural element is failing. Yellow means warning, and so these are the color codes. So right now we are all our design elements, the beam, the column, and the slabs, they all show green, saying that it is perfectly okay. So this is how we perform our structural design. Like I said, this is a practical base. If you also look at the 3D to see if maybe we'll see any other color. Okay, we have only green color. So our structural design analysis is perfectly okay. So with this, we can go back to plan view. So we go back to, we go off from the visual interrogation. Say none. It's okay. So this is how we perform our building analysis and design, and this is how we do our structural design using Protastructure. Now the next stage now is to go for structural detailing. This is a practical base. Now, despite that, when we viewed our visual interrogation and our design status, knowing that every element, which is the column, the beam, and the slab, they are showing green and they're showing okay, which symbolizes okay. I always like to check my beams one after the other to know the kind of reinforcement the program is given to me. If I'm not okay with it, I have the right to change the reinforcement on that member. So I'll start with the beams. I'll quickly click on the beam on the first floor and go to beam design reinforcement for just this active story. I want to check. So I'll wait for it to come up. So it's always good to check the beams to know the kind of design the program performed, because to see if the program use the kind of specification you like specified for the reinforcement. We used only Y16 for the reinforcement of all beams. Now this program can go ahead and give you a reinforcement size of 25. Why you don't need that? That's why you need to check the beams one after the other. So with this now, I will start checking my beams. I'll have to double click or just say interactive design. So performing the interactive design for each of the beams. I'll click on this first beam to check what is there. If it's okay, I'll just, normally it's good to check one after the other, but because of this lesson, just to kill time, I'll just pick some of the critical beams like this and this one and this one and maybe one of the simply spotted beam and check. But on your own, when you're doing your design, it's good to check all the beams and also check the columns too to know the kind of reinforcement detail that the program gave to you. So, okay, so this is it right now. We have 2y16 up and 2y16 down. So for me, this is okay. I'll click on OK and I'll go to the next. Like I said, you have to check all. Go to the next. We have 2y16. It's okay for me. I go to next. For me, this is okay. I go to next. I'll wait again. Now, if it's not okay, but for the ones I've checked before, they are all okay. So this is okay for me. 2 is okay for me. Up and down. 2 is okay for me here. 2 is okay for me. I'll say okay. I'll go to next and say this. Now in this area now, this is okay for me up. This one is showing 3. If I have to reduce it now, it's failing here, so I'll have to increase. So with this, I'll increase this place to and increase this place to 3. With that, this is too small, 30. I'll increase to 3, number 3. With this place, I can increase to 3 too. So with this now, you can see that you have the right to change the quantity of reinforcement and how you want your reinforcement detailing to behave. So you can say okay. Go for the next again. And okay, this is okay for me. You go again. So this is how you perform your interactive design. It's okay for me. I say okay. Next again. This is okay for me. So I'll say you quickly, you just check. This is okay for me. Go for the next. This is here is okay. I move to okay. This is okay for me. Okay. This is okay for year 3, but I want it to be 3. I want it to be 3. Yeah, it's to be 3. Now, I want it to be 3. No, this is 2 is okay. Now, on this span right now, I want this span is requiring 6 reinforcement because of the length of the beam, which is 5.145 meters. So, but right now I want this reinforcement to lap inside this column and inside this support. So I'll quickly say lap on the right and lap on the left. So it's not lapping right now. So when I have let me use it to be 4 so that I will use the same reinforcement to run all across. Then reaching here, I can now reduce to 2. That's why I say you have to check. You have the right to check. You have the right to do your interactive design, to tell the software what you want. You have the authority to give rights to the software to behave the way you want it to behave. So I'll click OK and go for again, continue again. This okay for me. This is okay for me. Go again. This is I have to lap. This is not okay for me. I have to lap to the end. Lap to the end. Okay, this is okay for me now. No, let me come back to that place. I don't like that. What's happening there? I want this to be 3. Okay, yeah, it's okay for me now. I'll go again. Okay, I'm okay with this. Go again. I'm okay with this. Go again. I'm okay with this. Go again. And I see that. Okay, I'm okay with this. Okay, I'm okay with this. all these beams, these ones, they all have small lengths. Now I'm not okay with this. It showed me just one diameter Y16. I want to be 2. So that's why I say you have to check. Okay. This same thing here. I want to be 2, not 1. I'll now say okay. Now you see we properly checked all the beams. Now with this now, you can now close this one. Now doing this now, you now know that your structural detailing will be based on what you want it to be and not what the software wants to give you. So I'll go again to the roof beams and do the same thing on the roof beams. I'll carry out the same thing on the roof beams to perform my interactive design on the roof beams. So I'll also check all. This is okay for me. This is let me see. This is okay for me. Yes, it's okay for me. So you do the same thing for all these beams. Okay. This okay for me. This is okay for me. This is okay for me. This is okay for me. Okay, so now I've done. We have it here, steel bars 4Y16 and the lengths diameter 10 at spacing 175. Okay, I think I'm okay with this. Check it all. Okay, so we have done our structural analysis and design and also done our interactive design, our own design to give the software what we want as the end result to our structural detailing. So with this now, we can now go for our foundation design. On the foundation design for this structure, for a structure, you have to click on Storey 00, where you have to see only the columns. Now, the kind of the 5-bedroom duplex is a part foundation. So to do a part foundation for a concrete building, you just click on the column. After clicking on Storey 00, you click on one of the columns, right click and say insert part base. So you wait for the dialog box to appear. Now at this place, you have to fill in your parameters. I'll fill in my footing depth. I want my footing depth to be 300. So I'll take 300. I'll leave this the way it is. Then eccentricity 00. Then I've already filled in our soil bearing capacity, which is the allowable stress of soil, which is the bearing capacity of the soil, to be 135, from which we got from the geotechnical investigation. That base dimension is 1.1 meter by 1.1 meter. Now, the main thing you have to check on this foundation design for part base is to check for punching. So I have to check for punching check. For punching check, this place, the punching check must be okay at the face of the column. The punching check must show okay at 1.5 D distance from the face of the column, and also on direction 1 and on direction 2. You must show okay. The next thing now we'll check again is for the moment design. Now we check for shear. The shear at the face of the column must be okay, and the shear at distance D from the column must also be okay. So for the foundation design of a pad on Orion on a Protastructure to be okay, this punching check must be okay, the shear check must be okay, and the shear check on the other direction must be okay. Then also you look at your size of reinforcement and the spacing. Then you click OK. Then you now finally click OK. Now this is now our part base. To look at it to see how it is on the 3D view, I click and right click 3D view. You can see that we have designed the foundation, which is the pad foundation for this particular column. So we will do the same for all the columns that we have here. So I'll go back to plan view and continue. I click insert. So with this now, you don't feel anything again, because since we have already done our first filling by inputting the parameter, we'll have to use the same parameter for all. So you just say calculate square, check for punching, check for shear on both sides, and you say if they are all okay, you say okay, okay. The same thing happens here. Insert, calculate, square, check for punching and shear. Okay, okay, okay. Okay, the same thing happens. You just have to click insert, calculate, square. Okay, okay. Always check for punching and shear. Don't just click OK and OK. Check for punching and shear, calculate, square, click, check OK, OK, and OK. I click this, calculate, square, OK, 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 OK. Now this gives you the axial load. You can see it here, axial load moment. I just want to show you so they can see where you can get your axial load. Okay, okay. The same thing happens here. Calculate, square, check for punching, check they must be okay before you click OK and the final OK. Okay, I paused the video just to save a little time so that the size of the video will not be too much for you guys to watch or download. So now we continue again to insert our part foundation. Choose this area, these two. Well, okay, there is overlapping. So with this, it will now prompt us to have a combined base. So we'll have to create a combined footing for these two columns. So to create a combined footing, you just highlight the two columns by click and click insert part base, calculate, and square. The size is showing me 1 tray 30 millimeter. So I'll say okay, but I want to reduce the moment. We only use axial load. So this is how we insert part base for a combined footing. So this is single, so I'll just insert and I'll say plate, square, check for punching, check for shear. They must be okay. No one must show fail. This should be a combined base. So I'll put this, right click, and I'll select the two columns, right click, and choose combine selected footing, and I'll right click and I'll click on insert part base and then calculate square and check for shear, and I'll say okay and okay. If maybe the size is not okay with you, maybe you want to use 1.2 by 1.2, you just delete this and click it by click, insert part base, calculate square, then you have to increase it here, 1.2 by 1.2 that you want, then you say okay and okay. Oh, it's not centralized, so I come back. It's not centralized, you can see that, so I'll just delete. I flip it to again, insert part base, this is how we insert part base. So looking at this now, we are done with our really like to see this axis. I like to see them clear, so I'll just turn off this axis right now by clicking here. So the axis will be turned off. Axis will be turned off, just seconds. Okay, you can see that the axes are turned off already, so you can have a clearer view of your 3D model. If you want to turn back the axis, you just click back here, it will be turned back. So but I like to leave them off. Leaving them off doesn't have any effect except when you want to insert anything. So now this is our this is the combined footing, you can see, and this is the combined footing on the other side, you can see them there too. So this is, we have done successfully a structural design for this 5-bedroom 1-story concrete building. It's for residential purpose, so you can see that we have done all the way from importing from AutoCAD down to this stage right now. So this is a full lesson or a full class for structural design of concrete of a concrete building using Protastructure. Okay, so let's go back to which is the structural detailing. Then we'll now enter into drafting, which we'll use AutoCAD to prepare our drafting. Okay, so let's get started for the next stage. Okay, so after you just finished your building analysis, the next thing to do is to produce your structural details, such as the slab details, the beam details, and the column details and foundation details. So first, we will have to start with the slab detail. To create your slab detailing in Protastructure, you click on slab strip. When you click on slab strip, a dialog box will appear, which you have to select the kind of end conditions that you have. So we will start with X direction, which is the X axis. Now, on the X axis, we have two options here to pick, which is at start and at end. This simply means that what kind of slab do you have at the beginning where you want to start to cut your slab strip. So at the beginning, this is our beginning. We want to cut through this slab to detail this slab. So at the beginning, we have a discontinuous end. So there is no slab on this end. So we'll pick a discontinuous at the starting point. Now, coming to this end, we have a cantilever end. So we will pick a cantilever end at the end. So now, we'll now have to click and then move our mouse across. To make this line straight, you hold your control key. So I hold my control key and just click a little bit after the slab. Automatically, you can see our slab reinforcement is already showing that the slab is already detailed. Okay, so the next thing I'll do is to detail the vertical axis. So I'll quickly change my directions to Y. And then at the starting here, we have a cantilever, and at the end, at this place, we have a discontinuous end. So I'll click my starting to be cantilever end, cantilevered end, and my end to be discontinuous. And I'll click and go across, hold my control key and click. Now this slab has been detailed both in X direction and the Y direction. The next thing is this area. So in this area now, I will have to cut this slab all through down. So cutting this slab all through down now, we have our end condition here, which is starting cantilevered, and down here we have another which is cantilevered also. So I'll quickly pick cantilever. Then I'll click at this point, hold my control button down and click just across it. Sorry, delete, and come back again. We have cantilevered. Okay, so we now have the slab reinforcement on this axis. The next thing we'll do right now is to detail this axis, which is we are still on Y. I'll quickly click. Now, what is our change? Okay, we now have this end discontinuous, so we'll pick a discontinuous end and then go again, click, and then go down and then click again. So we have this here. Now, what if there is no cantilever? All we have is discontinuous and discontinuous. Let me see if we have, okay, we have that. There is no cantilever on this area. We have a discontinuous end and also a discontinuous end. With this kind of thing, what you do is to pick discontinuous and discontinuous. So you click, go across, hold your control key and click. Okay, now we do the x-axis right now. The x-axis of this slab, these both ends have cantilever. So I'll quickly pick cantilever and then go across and then click again. So with this, so now to cut your slab section, through this slab, to see the slab section, you go to floor plan section, click on that icon. Just the same way you cut your slab strip, you click and then go across, hold your control key and then click again, and then you'll be asked where you want to paste. Just quickly go up or you go anywhere to paste and then click. Automatically you can see your slab section showing you this is a support on this end, this support is this support, and this is the span showing here. This support here is this support, and this support is this support, and this is the cantilever slab which shows here. Okay, so this is how we detail our slab in Protastructure. The next thing we'll be doing right now is to detail our beam.